Hello there, this is Alex from DBOS. In the last video, I went over several features of DBOS Transact and DBOS Cloud, and this time I'll focus specifically on our reliability guarantees and workflow recovery. This is the online store workflow that I mentioned last time. As soon as a customer starts a purchase, we take care to reserve inventory so that two people don't end up buying the same item. If there's a problem processing payment, we need to make sure to release the reserved inventory so that it can be bought by someone else. And if there's a crash during this workflow, a naive implementation may be stuck in an inconsistent state that requires an expensive manual fix. So let's see how DBOS is different. We'll use an open source demo app that implements this workflow. We'll crash the app mid-purchase, and we'll show how it automatically recovers to a correct state. Here we are at the Widget Store app deployed online in DBOS Cloud. This confirm or deny payment screen simulates us calling out to a payment processor. Confirming payment fulfills the order, so we just bought a widget and now there's only 10 left. Denying payment cancels the order and releases the inventory back. The inventory is reserved as soon as we press Buy Now. We can verify this by connecting to the app's underlying database and querying the products table, so we see the inventory count as now 9. Now that we're in this mid-workflow state, we're going to crash the app. This is not a standard feature of DBOS apps, but something we've added to this app to showcase our reliability. I'll click this button and then I'll go back to our payment screen and try to refresh it and find that it's not loading. We'll go to our app's dashboard and look at the log. Here we see a log line for the app becoming unresponsive caused by us crashing it. And if we refresh and give it just a few more seconds, we see that DBOS Cloud is already restarting the app here. There's even a log line indicating that we were in the middle of a workflow while we crashed, and now the workflow is being recovered. If we go back to our payment confirm or deny screen and refresh it, we see we are back to where we were. The suffix at the end of the URL is something we call a workflow UUID. It is an idempotency key used to uniquely identify and track a specific instance of this workflow. We can deny the payment, our order is canceled, and the inventory is properly incremented back up to a count of 10. Now, if we hit the back button and navigate to the same payment page with the same key, this particular implementation will display the payment page, but this workflow instance is already finished. So clicking a different option here will not create a new order, alter the state of this order, or change the inventory. And of course, the app is perfectly usable just as before. You can read the code for this app on our GitHub repo called DBOS Demo Apps. This is the core logic of the workflow. Here we can see the point where we subtract the inventory, create the order. Here is a dialog where we ask the client for a payment confirmation, and there's actually a 2-minute timeout here. After 2 minutes expire, we consider the payment denied. So after we crashed the app, we technically didn't even need to press the deny button. And finally, we either fulfill the order or undo the inventory decrement. Note that there's nothing here about handling crashes or anything like that. This is all automatically handled by DBOS Transact. You could crash the app at any point in this code and still get the same behavior. You can deploy your own version of this app to DBOS Cloud for free right now. And you can reach our team on Discord if you have any questions. We look forward to hearing what you think, and thanks very much for watching.